Okay.
Okay, so we've got 1 over x is our most basic inverse graph. So what we notice is that if you were to make x, say, 1, you'd have y being 1. If you were to make x a half, 2, you'd have y being a half. So what the inverse graph looks like is, so when y was 2, so 2 and then a half would be something, say, like that. Like x was 1 and say 2 there. What we notice is that as x gets bigger, y gets smaller. So as x gets bigger, y gets smaller. So we know that our general format of the inverse graph goes like that on the one side. Now, when we make, say, x minus 1, then y becomes minus 1 as well. So that's sort of over here. And then if we make x minus 2, y becomes minus a half. So y goes towards the top. It gets closer to 0. If we make x minus 4, 1 over, it'll be negative a quarter, which is, so it's getting closer and closer to 0. So our inverse graph always looks like that sort of shape.
Yeah.
So whenever we look at an inverse graph, we have to remember that it looks like this. And then if it's a negative, so if my number, say 1 was, say, I don't know, it could be even like negative 2 or something, over x, then what happens is it flips. And so we end up having a situation, instead of being in the first and third quadrant, it goes in the second and fourth quadrant. So we just do that in color. So if this value is negative at the top, we have our inverse graph looking like this. Okay, in pink. So it's the same shape, but just flipped. Okay, so that's something to remember for the inverse. The shape of an inverse graph looks like that. Now, what we notice is that you never get to 0, because 1 over, say, if you make x a million, 1 over a million is just a very small number, but you can never get it to 0. It'll just, as x gets bigger, it just gets close to 0, but it never touches. And so y will never get to 0. And so we must remember that we always have this asymptote in an inverse graph, what we call the horizontal asymptote. And in this case, your horizontal asymptote is y equals 0. We also notice that our x never gets to 0 either. So we have another, well, when I say that, I mean, x cannot be 0, because watch what happens if I make x 0. Well, 1 divided by 0 is undefined. So we also have this asymptote here, and I've drawn them in green and blue on purpose, because, so here we have an asymptote of x equals 0. Now, these asymptotes change, but the shape of the graph doesn't really change. I mean, you could change the a to be a bigger or smaller number, and it might change it sort of, so it goes like this, or, you know, goes closer to the axis, but it's always the sort of same shape of, so it's always like this. You know, it could be like this, and like this, or like this, but it's always these two kind of crooked smiley faces.
Yeah, it keeps a general shape like that.
Yeah, so that general shape is the same of an inverse, but what happens is we notice that these asymptotes are the things that shift. And so this 3 here just so happens to be the green asymptote here. So instead of being, we notice here that we could almost say that, we'll do the green first, that this 1 over x that we drew, 1 over x, not we could say has a 0 plus a 0. So that's the y equals 0. And then, of course, the blue one is you cannot have this bottom being equal to 0. So that's why that one's 0. So to start off with, if we looked at this, now we're looking at this example here, which I'm going to draw in pink. So this example here, we'll look at the 3 first. And so the Q3, this Q, you asked what the Q means. The Q means the horizontal asymptote. And so I could simply just write, draw my asymptote like this, and just say y equals 3. Okay, and then what I could do is I could draw my x asymptote as well, my vertical asymptote. Now, the reason I put a minus p in is because it shifts counterintuitively. So in other words, the y is intuitive, because if it's plus 3, it goes up 3. If it was minus 3, it would go down 3, but this is not intuitive because plus 2 actually shifts it backwards. The reason being, if I look at this, how do I make the bottom 0? I would have to make this a minus 2.
Yeah, exactly.
I hear you saying it. Good. So this, your x or horizontal asymptote is actually x equals minus 2. Okay, so if I have a plus 2, this becomes minus 2. Okay, so what I'm going to do is I'm going to delete the old asymptotes. Actually, I'm going to keep them there. But what I'm going to do, instead of redrawing the graph, so I'm just going to move, because essentially what we're doing is we're just moving. And we're using now the new asymptotes as a guideline for where to put my graph. So do you see I shifted it up there and across and over there? And
I see that.
Move it up as well. Okay, so in that first one, when it was here, so let me move back to where it was. You notice that it doesn't actually have an x and a y intercept. So I don't have to work them out. But if I have the asymptotes shifting, I notice that I actually do have some asymptotes. So I mean some intercepts, so I have to work them out.
Yeah.
And that I just do as I normally do for functions, right? So let's do the y-intercept, do that in yellow. So y-int, what do I do?
You make x 0.
Good. Okay, so 3 over 0 plus 2 plus 3, and I get 3 over 2, which is 1.5 plus 3, so we get 4.5.
Yeah.
That makes sense.
Just gonna take out my calculator.
4.5.
Yeah, it does.
Okay, then I'll do my x-intercept, which is when you make y equal 0. And so 0 equals 3 over x plus 2 plus 3. So this now shifts to the other side. So we have minus 3 over x plus 2. Well, for this to be minus 3, the bottom has to be minus 1, because 3 over minus 1 would give us minus 3. So x minus 3 plus 2 would be minus 1. So I can see that it's minus 3, which does make sense, because if this is 2, this is minus 2, then this would definitely be minus 3. You may not be able to work it out in your head all the time, so let's just see it, how we would do it in a better algebraic way. We would take the x plus 2 to the top of the other side, because it's the bottom of the right-hand side.
Yeah.
And then, well, this is just negative 3 over. So technically, if you had a 2 at the bottom, that would go to the top of the other side. So it would be minus 3 over 2. That it would be then 3 times 2. As it stands, there's just a 1 at the bottom. This is just like saying 3 over 1. So yeah, it's basically just 3. And so we'd say minus 3x minus 6 plus 3 negative 3x equals 9, 9 plus 9. So x equals minus 3. Okay, so now that's done. We've been able to sketch the inverse graph when we're given a function. So the most important thing is our asymptotes.
Yeah, exactly.
Now there is one other thing which I'd like to do, and that is to show you that these functions have axis of symmetry. Now,
Okay.
if I was to go and move them back to where they were, the axes of symmetry are like lines where if you were to have, they mirror each other. So I'm going to do it in orange and purple because I haven't used that yet. So purple, you'd have like that and like that, sorry, and like that would be the axis of symmetry. So it cuts the graph in half. So this one here is y equals x, and this here is y equals minus x. Okay, so those are simple ones, but now let's move it back to how it was and have a quick way of getting our axes of symmetry for this graph here. So I like to use a visual method of doing it, and that is if we look at our function, so I'm going to rewrite it again. Y equals 3 over x plus 2 plus 3. What you can do is you can actually take this bit of the function. Sorry, I'm going to do it in purple. That's axis of symmetry. Now we noticed from before there's always 2. So you just take this bit here.
Okay, so
and so we write that bit out, y equals x plus 2 plus 3. And then the trick is literally just to put a bracket here, and say plus and minus. And that'll give us our 2. We take that, we write it again, we put the x plus 2 in brackets, and we say plus or minus, and that'll give us 1. So the first one will be the plus, right? So plus x plus 2 plus 3, so y equals x plus 5. Down here, y equals x plus 5. The other one is the minus, so that'll be y minus x minus 2 plus 3. So y equals minus x plus 1. So we notice if we had done the y equals 1 over x, it would have been just y equals plus x and y equals minus x, which makes sense. But it's a really easy way, the visual way. So just write it out as you see it, and then a plus or minus. So let's look at the x plus 5. So remember that y-intercept then would be 5, which would be about here. And the x-intercept would be minus 5. There.
Okay.
So that would be this line here. I'll draw it.
Oh, yeah. Very nice, eh?
Okay. That was pretty perfect, actually. And then minus x, so the y-intercept would be plus 1. Out here. And then the x-intercept would be, that would go across, become minus, would be 1. So that'd be there. And so that one sort of goes like that. Okay, now they should usually, I think, cut at right angles, but they don't always. Actually, they should always cut, because we notice that the gradients, when you multiply the gradients of this one is 1 and this one's minus 1, you get, so they should be perpendicular, but because I didn't draw the graph to scale, these should be right angles here. But it is correct as well, because they always cut through, they meet at the two asymptotes. Do you notice? So this
Yeah.
blue asymptote, this green asymptote, the lines go through them. And so these are the two axes of symmetry. So if they ask for the axis of symmetry, that's what you do. So this one is y equals minus x plus 1, and this one is y equals x plus 5. Okay, so if you just had joined this lesson now, you would look at this and go, what the heck is going on? But
Yeah.
hopefully you followed each step. But what I'll do is I'll post this video and I'll just send you a link and then you can watch it again.
Yeah, perfect.
But hopefully that's all clear now.
No, but I mean the color coordination helps, so I think.
Yeah, I hope, like the London Underground.
Exactly.